G'day again, back for question 6. What is the period of the function fx equals tan 3x? If I was in the HSC and I was in an exam, I'd immediately draw up two quick graphs, just so I've got my head around what's going on. I draw a quick sketch of just tan x. Alright, so y equals tan x. Now we know, or you should remember, that tan x goes like that. And I will draw it only to there, and that's 2 pi. So that's pi, and that's 0. So I'll draw that, so that's in my head. I'll go, okay, that's tan x. What does tan 3x look like? And most of the time you're not given tans, you're usually given sine or cos. And you should know, if we just quickly look at, let's say, a sine curve, if you do that, and you say, well, that's y equals sine x, you should have done a lot of practice, I would hope, if that's 2 pi and that's 2 pi, that if I change this number here, so y equals, let's say, sine 2x, that this is going to double. But instead of getting one loop, you'll have two. So you'll have 1, 2. So you have two of these sines in here. So the same thing's going to happen if I put a 3 here. Instead of having one here and one here, in this space, I'm going to have 3 of them. So I would have this, and then before I get to pi, which is where it repeats, so pi is the period, it's going to have 3 of them, so it's going to go another one, and I'm not going to be very clever at drawing this, 2 of them, and 3 of them, and it's going to go through there. So you'll have 1, 2, 3 in the same period where you would have 1, you've now got 3. So it's occurred 3 more times. So what is the period? Well, the period is this gap, and this gap here is pi between there and there. Well, this gap here is now pi on 3. There's 3 lots of them. This gap here, if we did this, well, this gap between this point where it repeats there is 2 pi, and this gap here is this gap here is pi, and this gap here where it repeats is 2 pi. So that period is 2 pi, that period there is pi, that period there is pi, just for a normal tan, and this period is pi on 3. So your answer is A, pi on 3. G'day again, back for question 7. The circle centred at O has radius 5. Arc AB has length 7, and they give you this nice diagram here. What is the area of the shaded sector AOB? If you look through the answers, you'll notice there's a few pi's in there, so that should be a giveaway to say they're looking for an answer in radians. It's pretty easy because if you go to the back, if you're forming the sheet, you'll notice you've got these two formulas and they're both in radians, so you don't have to figure out degrees. It's really just a little bit of algebra. So the arc length is r times theta. We want to find out what theta is, so we can put in the arc length and the radius. A little bit of algebra, not much. 7 equals 5 multiplied by theta. So 7's our arc length, 5's our radius. Really simple algebra, divide by 5. So 7 on 5 is theta. That's our first step. Second step, we want to put that in there, and again we know what the radius is, so the area equals a half r squared, so 5 squared because that's the radius right there, multiplied by theta. Now we've just figured out theta times 7 over 5, and they've made it pretty easy. Cancel that, half times 5 times 7, well, what's 5 times 7? 35. On 2, and bingo, you've got your answer. It's A, and you're done. G'day again, back for question 8. How many solutions does the equation absolute value of cos 2x equal 1 have for x in between 0 and 2 pi? I think the best way to do this is to draw this equation. So if I'm in the HSC, I'm going to quickly draw cos x. So there's my cos x, and there's 2 pi. I want cos 2x, so I'm going to draw that one. So instead of just one loop, I'm going to have 2. So I'm going to go, let's see how we go. 1, and 2, and 2 pi. And now I'm going to think, I want equal to 1. Well, where does it equal to 1? Well, we know it must equal 1 here, so 1, 2, that equals it 3 times. But we've got the absolute value. So what is the absolute value here? Well, that's -1. The absolute value of this point is going to occur here at 1. And the absolute value of this point is going to occur here at 1. So the curve will actually look like that. And this bit will disappear because you've got to have everything positive because it's an absolute value. So you would end up with 1, 2, 3, 4, 5. 5 values, and your answer's D. And you're done. G'day again, back for question 9. What is the value of the integral between -3 and 2 of the absolute value of x plus 1 dx? What you should do when you get a question like this, because it's negative, is actually to draw it. Now, I've drawn that in there. That doesn't come with the question. You would have to actually draw that in. Highly recommend it because it's very difficult to figure this out, especially when you're going from a negative to a positive, and especially because this is absolute value, which you're probably not really used to. You've been more used to something without the absolute value sign. So I would draw that, and the two equations you are drawing is y equals x plus 1 and y equals minus x minus 1. So they're your two equations. And the first thing is you've got to realise that they are your two equations from there, okay? So if we draw these in, y equals x plus 1, we know it's going to pass through 1 and therefore have a gradient of 1. So it will go like that. Let's try and draw it straight. It will go like, roughly like that. And that will actually pass through 1, but I've missed. And the other one, y equals minus x, well, it's got a -1 gradient and it passes through -1. So it will go at 90 degrees like that, okay? So if we look at those and we say, well, we want this between 2 and -3. So if we dot down there and we dot down there and you've drawn them with any sort of accuracy, you'll notice that this line lines up with the 2 and that lines up with the 3. And you can test that out by putting in points. You can put in x equals -3 in there and say, well, -3 plus 1 is -2. Absolute value, well, it does equal 2. Put in 2. 2 plus 1 is 3. So yes, you've got those drawn properly. One way to do it would be to integrate these in between those two areas. So you could say, if I integrate minus x minus 1 in between -3 and -1, because we're going from there to there with this line, plus we want to integrate between -1 and 2 of x plus 1 dx. I want a dx in there too. If I integrate those, you'll get minus x squared on 2 minus x plus x squared on 2 plus x, and you substitute in your points, 2 minus 1, and then you substitute in these points of -1 and -3, and you fill out all the numbers, and you put the -1s in, take away that, do that, and you ultimately end up with an answer of 6.5, which equals 13 on 2. So you do get that answer. But there's a quicker way to do it. Having drawn this, what you need to realise, or just remember, the integral is the area under the curve. So we just want this area plus this area. And look at that, they're both triangles. So you should be able to go half the base times the height. Well, half of 2 is 1, times 2 is 2. So on this side you've got 2. And then the other side you've got half the base. Well, that's 3. Well, half the base is 1.5 multiplied by the height, which is 3. Well, 1.5 times 3 is 4.5. So 2 plus 4.5 is 6.5. And again, you get the answer of C. But this way is much quicker if you're dealing with absolute value. This works. It's a lot longer. And again, you'd be writing out the lines there. But either way, you get the right answer. But I would suggest try and do it that way. And you're done. G'day again, back for question 10. Which expression is equivalent to 4 plus log 2 log base 2x? And then you've got a bunch of answers. I would just write this question out. So 4 plus log 2x. Look at the answers and you've got 2, 2, 2, 2. So what you want to do is change this into base 2. So we want log something base 2 is 4 plus log 2x. Well, what number here have we got to put in so that we've got 4? And you just think of your basic log rules. So your basic log rules say log 2 of something or other equals this number 4, and this is your power. So this 4 is your power. So log of question mark is 2 to some power equals that. So 2 to the base 4, or so 2 to the power of 4 equals this question mark. And this is a typical log rule. Well, 2 to the 4, 2 times 2 times 2 times 2, there's 16. So this is 16. So log 2 of 16 is 4. So now you've got log 2 of 16 plus log 2 of x, and you've got a plus in the middle. So again, you're going to use another log rule. So let's wipe that out, give us some space. So we just want to add this together. What do you do with adding? You multiply. So you're going to go log 2 16 multiplied by x. And that's it. So we've got log 2 16x. Is there an answer like that? Yes, there is, right there. And you're done.